All right, let's go ahead and get back into it. So any questions before we jump back into power strips? Go ahead.
So on the homework, like it asks like, like two values or whatever, like where X converges or whatever, like what would you put and how would you plug in?
So we're not done.
Okay.
So yeah, we have a little more work to do to figure that out. So yeah, maybe hold that for like 5 minutes. We left this one kind of midstream. So just to kind of reset the stage, the question has kind of been the same for each one of these and for like ever since we started talking about sequences and series. The question we're after is, does the thing converge? Does the thing diverge? With Yana last week, you added a little more specificity to that. So if you say a thing converges, you can talk about how it converges. Is it conditionally or is it absolutely? Now we're getting into these new kinds of series, power series, where we can give like a list of situations or an interval for X where this thing converges. So last time we got down to this limit here. And under what conditions does the ratio test give convergence? Less than 1. So strictly less than 1. So that's why I have this limit here set to less than 1. Is this a limit we can evaluate right now? Or would you like to do a little more work? I can pull out the x squared root of 4, so this is equal to, by the way, it's squared, so I'm going to take the absolute value off. Also, I don't really need, I know that n will never be negative, so I'm just going to treat it like this. The limit as n approaches infinity of 1 over n plus 1 squared. And I want to keep that less than 1. So now that remember, these limits are only looking at what happens to our sequence as n gets very big. So I can pull up anything that is not governed by n. So now that we've done that, can I say anything about this limit? 0. Goes to 0, right? So basically, what do I get here? I get that 0 is less than 1. So basically, the x here got canceled out. So basically, I got that this limit, this ratio goes to 0. So what does that mean about the value of x for which this thing converges on?
It could be all sides.
All of them, right? So it does not matter what x is, this thing converges. So because of that, then on what values does this thing converge? For all x, all real values of x. So basically, this is kind of like the other extreme from this one here. For this one, we said that there are no values of x, or no non-zero values of x for which this thing will converge. If you let x be anything other than 0, the series will get too large and it will diverge. And this one's kind of the other extreme. Doesn't matter how big you allow x to get, the way this series is defined, it will converge. Any questions on how we made this conclusion?
So would that be absolute convergence?
No, absolute convergence is a different idea. Absolute convergence has to do with whether you're looking at the series itself or whether you're looking at the series built of the absolute value of all the individual terms. This converges everywhere for all values of x. Also to that point, when you're looking at the ratio test, you're kind of by definition looking at absolute convergence. Do we understand why?
Because you put in absolute.
Yeah, the ratio test is kind of defined on the absolute value of those terms. So you're already looking at absolute convergence. So we've kind of seen the 3 different ways that a power series can converge here. So if you have a power series, and this is what they all look like, I think this is almost identical to like the way I showed it to you before, except for this minus a. Basically, your power series doesn't have to be like centered around x equals 0. I can offset it by dialing in that value of a. But a power series has to behave in one of these three ways. It converges only when X is. It converges for one value of X and no others. So that's kind of the worst case scenario. You can take a power series, but it's kind of useless. It only converges at one place. Or it converges absolutely everywhere. So those are the kind of two extremes. And then the intermediate case is you have something called, which I don't think I've used this term yet, but this R. This is called the radius of convergence. Basically, there's a finitely long interval where your power series converges inside that interval, diverges outside of it, and then the only real doubt is what happens on the border, what happens on the boundary. So we've seen all three of these things so far. And this is the complete list of things that might happen. Like, for example, you're not going to get a power series that converges for positive values of X. It's gonna, if it has bounds, it's gonna have bounds both a lesser bound and a greater bound. How we do? But basically, the way you find these kind of behaviors of convergence is almost always done through the ratio test. All right. So we look a little deeper.
Well, can you go back to?
Absolutely.
Wait, it's just. Can you explain what the divergence part, so like the absolute value? Like,
Yeah, so basically what's going on here is, let's give a number here. Give me your favorite number. Excellent. X minus 3. And give me another number for the radius of convergence.
2.
2. Okay. So we can unpack this a little bit, right? If I say the absolute value of X minus 3 is less than 2, can I reinterpret that somehow? Like, can I rewrite this? Can I rewrite that without absolute values? So one way to think about this is, if I say the absolute value of something, basically what the absolute value of something tells you is how far away it is from 0. And I don't really care about what direction it is. I just care about how far away it is from 0. But if I have absolute value of X minus 3, then that means I care about how far away I am from 3. How far away am I allowed to be from 3? Up to two places, right? So basically I can be between 1 and 5. So that's one way to think about this. Another way to think about this is we can kind of re-express this algebraically. For the absolute value of something to be less than 2, that means that it has to be between 2 and negative 2. Does that kind of make sense with the number line that I'm using to illustrate this here?
Yeah.
Okay. Can I now solve for X in this inequality? So basically, if I add 3 to all branches of this inequality, I get 1 is less than X, which is less than 5. So basically, if I have my center point being X equals 3 and my radius being X equals 2, that gives me this. For all values of X between 1 and 5, I have convergence.
Okay.
So one thing I haven't specified here is, so the radius of convergence is 2, right? Basically what that means is, as long as you're within 2 units from wherever the center is, in this case, Bella, you chose 3. As long as I'm within 2 units of 3, I converge. A little more specific is this thing that I just graphed up here. This is called the interval of convergence. And for me, this interval of convergence would be, I'll write it a couple different ways. One is less than X, which is, I already wrote that. Or the open interval 1 to 5. So basically, the interval of convergence is a more specific thing that kind of has that radius of convergence baked into it. Go ahead.
Is the radius of convergence something you give, that just has to be like solid work?
That's something, I mean, typically I will not give it to you. Like I said, it's kind of like. That's something you will be able to calculate almost always with the ratio test. Because basically the ratio test. Basically tells you how far away you can be from the center. Before your limit, before that ratio. Reaches 1. So if we go back and now that we've kind of talked about the vocabulary. That's kind of what we're doing here is. We know, we care about where this converges. And once again, we're. For the ratio test to signal convergence, what does it have to tell you? Like, what does the ratio test have to be? Has to be less than 1, right? So. We failed to find any values for this, but basically what we're looking for is, we're looking for the values of X that are gonna make that ratio 1 or bigger.
So then what is the radius?
No, 1 is not the radio, basically 1 is the condition for the ratio test. So. Just back up to kind of talk about why the ratio test works the way it does. So. Basically, this is the limit I'm looking at, right? As n goes to infinity. So as n gets really big, I'm looking at back-to-back terms. And finding that ratio. Essentially what I'm doing here is I'm trying to see if the series I'm looking at. Eventually acts like a geometric series. Because I have a really good idea of when geometric series converge. When do geometric series converge? Under what conditions? The ratio between -1 and 1, right? So -1 is less than r, which is less than 1. Or equivalently, that just means your r is within 1 of 0, right? So the absolute value of r is less than 1. So that is where the condition of the ratio test comes from. I'm treating it like a geometric series. I want it to act like a geometric series that converges, which means I want that ratio to be less than 1. And since I'm looking at the absolute values, it can't be negative. What else? I feel like 2 of you ask questions and I kind of went off on a tangent to actually answer what you want. Okay. Anything else? Okay, so let's look at another one. So I want to find the interval of convergence of this thing here. What does the interval of convergence mean? Right, so essentially I'm asking you the same question that I have. But now we have the vocabulary to back it up. How do I find an interval of convergence? Ratio tests, I mean, is usually a good thing to try. So the limit is n goes to infinity of what?
+1. X to the +1 over square root of that +2.
Okay.
Times square root of n + 1 over -3 to the n times x to the n.
All right, go with that. I have one small protest. Okay, so, but basically, ratio test is, as always, the limit is n goes to infinity of the absolute value of, you know, this ratio, this quotient of back-to-back terms. Go ahead.
Why is it square root of n plus 2?
Good question. Why is it square root of n plus 2? N plus 1 plus 1. So basically, we are everywhere. Basically, the n plus 1th term in this sequence is where I plug in a plus or n plus 1 for all those terms. All right. Is this a limit you want to evaluate, or should we do some stuff first? Tell me some stuff to do. Cross cancel, what cancels?
negative 3 to the x to the n.
Okay, what does that become?
Just or it's just 3 times x on the numerator.
So I believe yes, 3. There'll be a power of 3 in the numerator. For now, I'll call it -3. Power of x in the numerator, and what else?
And then we just have the square roots.
So the square root of n plus 1 all over the square root of n plus 2. I want this to be less than 1. Can I evaluate this now? I can pull up the -3x. In the meantime, I'll call this +3 times the absolute value of x. And then the limit of radical n plus 1 over radical n plus 2. So we got all this stuff that does not vary with respect to n out of the limit. Can we look at that limit now? What is that limit gonna do?
Can you explain why the -3 changed some?
Yeah, why does the -3 become 3? Absolute value, so basically. Maybe I'll write that first. Basically, if I pull this out. I'm taking the absolute value of -3x out. Maybe you don't know this, so I'll make it clear. If I have the absolute value. Of two things multiplied by each other. That's always equal to this, absolute value of A times the absolute value of B. So this is equal to the absolute value of 3 times the absolute value of x. What's the absolute value of 3? I don't really want to. Take it away from the x because x could be negative, and I don't want to lose sight of that.
And you don't have to keep it for square roots or squares. That's why you took it.
I mean, sometimes I go without it because, like, I think there's an example. Yeah, so I took it off of x squared because. There's no way x squared is gonna be negative, so the absolute value isn't really changing. Same with 4. 4 is already positive, so writing absolute value of 4 is not wrong, it's just not necessary. But you're not wrong to keep it there.
I was for the square roots as well.
For the square root, that's true. A square root, if it's defined, has to be non-negative. Oh, I see what you're saying. Yeah, so I left this off here and I'll admit it, I just forgot right there. But
But you don't need.
is it okay to leave them off in the square roots? It should be okay. There's no way a square root can deliver you a negative number. All right, so is this limit here something we can do? What is it? 1 over square root of 2? I don't think that's the case.
That was right, that's fine.
So. This will go to 1. So these are not polynomials, but. Basically, I have the square root of n plus, basically I have the square root of 2 consecutive numbers, right? N plus 1 and n plus 2. What's gonna happen to that as n gets very, very big? The 1 and 2 are gonna kind of get overwhelmed. So basically taking the square root of a number divided by itself. So I think that goes to 1. So now I have 3 absolute value of x is less than.
Solve that, so it's continuing.
Sure, let's do it. Square roots make it a little more complicated, but we'll get around it. Not as x goes to infinity. So this is radical n plus 1 over radical n plus 2. I can multiply both of these by radical 1 over n. What does that give me? Should give me radical 1 plus 1 over n over radical 1 plus 2 over n. Is it okay that I did that? What happens to n, or what happens to that is that goes to as n goes to infinity.
Turns to 0.
Radical 1 over radical 1. Yeah, good call. Don't let me get away with the hand wavy explanations. But yeah, that limit goes to 1. But
On a, would you want us to show the map and how we got?
yeah, so I'm very glad you brought it up. Yeah. To be honest, I took a little bit of a shortcut there because we've done a lot of these, but yeah, let's stay in the habit of really showing the complete argument. So now I got 3 absolute value of x is less than 1. Where should we go from there? How do we do that?
Yeah, that's.
Absolute value of x is less than 1/3. So what have we learned so far? X must be less than 1/3. Is that the only condition I have?
Can be greater than 2, that's what that's about. I'm not mistaken.
Greater than negative 1/3.
I can have negative x values.
Okay.
Because, so the absolute value of x needs to be less than 1/3. But that does allow me to have values of x that are negative. So basically what this says is, so I'll do the number line again. What's the center of my x values for which this thing converges? Kind of subtle, kind of hidden. But maybe I should rewrite this as the absolute value of x minus 0. So basically, this is going to converge for x equals 0. And I can also be 1/3 of the unit away from 0 in either direction. So here's what I know so far. I know that in between negative 1/3 and 1/3, I have convergence. So basically, here's my interval of convergence so far. Negative 1/3 is less than x, which is less than 1/3. So I know everything about what happens between those values, everything that happens outside of them. But what do I not know? I don't know if it converges at those values. We remember how to figure out what happens at the boundaries of those boundary values.
Or plug it into the series of
Right, so what is that? Yeah, plug that into. Basically, I got 2 x values I'm gonna try here. So let's just do negative first. If x equals negative 1/3, what does my power series become? So it'll be negative 3 to the n times negative 1/3 to the n over radical n plus 1. Can I simplify that at all? What's negative 3 to the n times negative 1/3 to the n? 1 to the n, which is always going to be 1. So basically I have 1 over radical n plus 1. Do I know what this series does? It diverges. Well, this is okay, and that's. When you say it goes to 0, what goes to 0? Sequence goes to 0. But does that mean the sequence or the series converges? No, it might. So it's not enough to tell you what the series does. But some of you did say the series diverges. Why is that?
P series.
P series. What's the p value here?
1/2.
1/2. Basically, I have a power on n, which is 1/2. What do I really care about? Like, what's the p series tell us? What's the condition for the p series for pass?
Constant, any constant over n to the p and exponent in the denominator is greater than 1,
Mhm.
then it's converges, but if it's 1 over. Or if like the exponent is just 1 and it's like less than that,
Right.
then it doesn't work.
So basically, the condition is. The exponent has to be not, I was gonna say at least 1, but that's not right. It has to be bigger than 1. What's our p value here? 1/2, because it's a radical. So here's what I know at 1/3. I have a fail to converge at x equals a third. But what about x equals positive a third? This would be -3 to the n times positive 1/3 to the n over radical n plus 1. How does this simplify?
One ten over root n plus one,
-1 to the n over radical n plus 1.
so that purchase again.
I don't think I think I can. Does the P series hold here? No. Why not?
Is because of the variable.
Because the alternating. So the alternating makes this a lot different. So we have to look at alternating series test, right? Don't have space to write all the conditions, but I'll write alternating series test. What are the conditions for the alternating series test?
If what's not alternating needs to go to 0.
Okay, so. What is the part of this that doesn't alternate? 1/square root of n plus 1. Does 1/square root of n plus 1 go to 0? All right, other condition we should at least make sure about, does this thing alternate? Yep, so we can use the test. Are all the terms so in the non-alternating part, are all the terms positive? Are they getting smaller? I mean, if they're going to 0, can I ask it? Go ahead.
What do you mean by the non-alternating part?
So, yeah, totally out of space. I'll try to use some geometry here. What part of this series, the way it's written, is the part that like makes it alternate, the part that makes it go from positive to negative? The -1 through the next, so this part makes it alternate, right? So basically, what's the rest of it? What am I multiplying that thing by? So basically, the non-alternating part is this block. So that's, if all the other conditions of the alternating series tests are met, you really are looking at the sequence. You're just making sure the sequence of the non-alternating part goes to 0, which it does. So what's my interval of convergence? I failed to include -1/3, but I must include positive 1/3. So here's my full interval. From -1/3 to 1/3, including 1/3. So we did a lot there. Ask me all the questions. Go ahead, Clement.
So you know that it's a constant next to the n, for the P series test from -1/3, is that still fine?
It is, because it's in the, yeah, it's fine, because essentially, if we wanted to, we could redefine this, right? I could say this goes from n equals 1 to infinity and just say that's 1 over radical n.
Okay.
There are ways to deal with that offset.
But you have to test the values every single week.
Yeah, so the ratio test, here's the reason why the answer to that question is yes. When x equals -1/3. This is the series we got, right? If we did the ratio test on this, we would essentially get like radical of n plus 2 over radical of n plus 1. That would go to 1. What does the ratio test tell you if you get a 1 out of it?
And
It doesn't give you anything, right? So the ratio test will give you this, basically it'll give you the open interval. But at those boundaries are exactly where the ratio becomes 1. So the ratio test can't tell you anything about those boundaries. So yeah, you will have to go look at 2x values using some other tool. Good question. What else? One more? Let's do one. How do we start? What's that?
Ratio test.
Yeah, pretty much. I just hate saying always, so like, I'm being cowardly and saying pretty much always, but. At least try it. But like I just said, the EV, sometimes you get to a situation where the ratio test won't take you all the way to get the completed number. So this ratio test. Of what am I looking at?
Plus.
Look good? I want this to be less than 1. All right. Does anything convenient happen for us?
Let's do it again. And
So what does that leave me? So should be left with all but one of these, so x plus 2. What happens to the 3's? Right, so I'm gonna be left with only 1 power of those in the denominator. And then the n plus 1 in the end. They stay. That's one thing I want to point out that I saw in the written homework is some. But yeah, so. Not that I was super surprised to see it, that's a very understandable. Impulse to want to do that, but. Yeah, we can't do any canceling then. All right. Now what? Simplified a lot.
well, I think it's 2 or 3.
Right. So I'm gonna pull out. Absolute value of x plus 2. Over 3. Times the limit as n approaches infinity of. The absolute value of n plus 1 over n. Question? All right. Can we. Deal with that limit now?
Yeah.
Does it go to 1? Why? Should scratch word.
But the top and bottom by 1 over n. Get 1 plus 1 over n.
So this is an equivalent limit. If I divide through by n. You get 1 plus 1 plus n, sorry, 1 plus 1 over n plus. You can see it. That comes out to 1. So now I get this absolute value of x plus 2 over 3 less than 1. So what does that give me? Yeah, what are the bounds gonna be?
Greater than -1.
So -1 is less than x plus 2 over 3, which is less than 1.
3.
If I multiply by 3 and subtract 2, I should get -5, which is less than x, which is less than 1. So just to kind of go ahead, so
I have a question. So why do you take out the x's because you only want the n?
yeah, basically, so here's the thing, we don't need to take out the x's. But the reason we can do it, actually, I'll ask you, why can we do it? Yeah, why can I pull the x's out of that limit?
Because we're taking the n. Which you-
Right, so basically, as far as the limit is concerned, that anything with an x is a constant. So, yeah, the only thing in the limit, the only thing allowing to change is n. So. Even though I don't think we've done it, we can, like, if we go back to this step here. We can take that limit as n goes to infinity there. If the x and the other stuff doesn't bother you. But if you'd rather, you can definitely take it out and. Reduce the number of things you're looking at. So I want to kind of tease apart some of these. New vocabulary terms. What's our radius of convergence here? Maybe it's hard to ask, but what's the center of our interval of convergence? How'd you get -2?
Much the difference between.
Right, so the middle of -5 and 1. Is it easier to answer what the radius is now that I've shown you where the center is? So what's the radius? So our radius is 3. So as long as you're within 3 units of whatever the center is, you're gonna get convergence. So right now, I have this, I have everything inside this thing, I'm gonna have convergence on. But I don't know what's happening at the boundaries. So what do I have to do to find out what's happening at -5 and 1? I have to look at those individually. So when x is -5, I get this series. N times -3 to the n over 3 to the n plus 1. Can we tell what that does? Should alternate, will it alternate? So maybe it's not obvious, but. Does anything in here cancel? So I'm gonna take this, this -3 to the n, I'm gonna write it as -1 to the n. Times 3 to the n. All over 3 to the n plus 1. Is it clear that I'm allowed to do that? If I write it like that, does it become clearer that anything cancels? So 3 to the n cancels the numerator. So what do I have in the denominator? 3. What does this sequence or series do? It alternates.
Alternating seriousness.
I think it does diverge. Actually, I don't know if it diverges by the alternating series test. The alternating series test technically can't tell you that something diverges. It can tell you that something converges, or it can tell you nothing. But I think there's other things we can do here. When in doubt, what should we do? Ratio test won't help us, but
Oh, yeah.
we can look at the first few terms, right? What's the first term gonna be? 0. Next one. -1/3. Plus 2/3. -3/3. Plus 4/3. That give us any more insight? Right?
Why are we not doing the alternating series?
Because I don't think all the conditions are met. So it alternates, right? What does the non-alternating part do? It goes to infinity, right? So I don't think we've met all the conditions of the alternating series test, but. What are the terms in the sequence doing here? Like they're alternating, but they're getting larger in magnitude, right? So I think this diverges by some other test, which is what? What is the sequence doing? What's the limit of the sequence? Can't really say it's infinity because it's gonna be positive and negative, right? But it doesn't converge, so there's no chance for the series to converge. So I would say the divergence test. Or the divergence theorem. Answers that for us. All right. What about x equals 1? So the series I get is n times 3 to the n over 3 to the n plus 1, which I think is the non-alternating version of the thing we just looked at, right? The series of n over 3. What does that do?
Just
Diverges, how come?
sequence, that's converged to 0.
Right, so basically also because of the divergence theorem. So basically this is going to be 0 plus a third, plus 2/3, plus 2/3, plus 4/3. So I found my radius of convergence, I found my interval of convergence, and I showed that this interval is totally open. The endpoints both diverge. Any questions? So I mean, there's kind of a lot that goes into these finding the interval of convergence of these things. How we do this? Okay. So that's all I got for power series, at least for that section. So we got a few minutes left. Let's start off. What was this, 8-5? That was 8-5. Let's start at 8-6 for a bit. So what we just looked at was basically I gave you a power series, and we can use some of the tools we've talked about to talk about where those things converge. Now we're going to basically go one level deeper here. Is I'm going to give you a function. We're going to write that as a power series. So this function right here, and just kind of looking ahead a little bit, any function I give you can be represented as a power series. So basically the next two sections here, we're going to talk about how to do that. So I want to represent this function as a power series. Do we notice anything about this function here? It's geometric. How do you know that?
By x.
Okay. So multiplying by x, multiplying by x, multiplying by x. Is that enough?
Yeah.
Okay. So I mean yes, it's geometric, but is that enough to help us write it as a power series? Really that easy? Write an x. There you go.
0 is 1.
So yeah, let's make sure. When n equals 0, what do I get? 1, and then. So I think this is fine. So I think this is a good representation of that infinite polynomial that I just gave you. Makes sense. So geometric series, like we keep talking about, there are things we understand pretty well. They're very predictable, and we have a good idea as to kind of how to represent their behavior. Anything else about this one before we go on? Okay. So this thing here, I want to express this as a power series, and I want to find the interval of convergence of that power series. So it seems kind of weird to think about this function. Basically, what I'm telling you is 1 over 1 plus x squared is equal to something that looks like this. Anything jump out at you about? How to get this done? One thing maybe let's talk about this one here. This is the power series, right? You said it was a geometric series. Can I find this sum? If it's a geometric series, can I find the sum of it? How do I find the sum of it?
A over one minus.
So the sum of the infinite geometric series is A over 1 minus R, provided what? Or absolute value of R is less than 1. What is my first term here? 1. What's my common ratio? So this function right here. Probably not obvious, but 1 plus x squared and so on, that's equal to 1 over 1 minus x. And it has everything to do with the fact that we know what the sum of geometric series look like. Because of that, can we say where this thing converges? Converges for x between what and what? -1 and 1. So this function can be represented as this power series, but only if x is within only if x is on a certain interval. So now that we've talked about that sum of geometric series, can we apply something similar here? Basically, this right here has the form of the sum of a geometric series. So if I kind of look for parallels in that form, what is my first term? What's my common ratio? Is it negative x squared?
You have 1 plus x squared.
Oh, it should be negative x squared. Why is it negative x squared, not positive x squared? Right, negative, yeah, 1 minus r, and I have a 1 plus x squared, so 1 minus negative x squared. So from there, does that help us write this as a power series? Maybe we should write out the first few terms here. You said the first term was 1. What's the next term in the sequence? Minus x squared, and the next one?
Plus 6 plus 4.
So I think this is what the series looks like, or what the terms in the sequence look like. Does that help us write this thing?
Negative x squared to the power of n.
Negative x squared to the power of n. Is that going to fit? If n equals 0, what do I get? If n equals 1, n equals 2. Okay.
Wait, how did you get these terms?
The ones that are listed here.
Yeah.
Good question. Where those come from? Right, so the bottom line for this is that this function right here has the same form as the sum of a geometric series. So because of that, I can think about. So I mean, if 1 over 1 plus x squared is the sum of a geometric series, if I compare, elements of this thing to elements of this,
Which is more common by the-
right? So my common ratio is negative x squared, and my first term is 1. So basically, I can build out that whole sequence by multiplying this term by negative x squared to get the next one, and then I can continue that indefinitely. So that's where these lists of terms come from. And then we can basically compact them all into this sigma notation to get the power series. So 11 o'clock, we'll figure out the interval convergence next time. Any last minute questions before we go? All right, I'll either see you all Friday or I have office hours at 1:30 today.